gelukkig hebben we ook een gast die alles weet van digitale veiligheid. Dus Chief Security Officer bij Rapid7. Hier is Jaya Baloo.
Jawel!
What I want to talk to you about in English is how to create a secure quantum future. First of all, we should recognize that a quantum computer later is going to be something that we desperately need to have because we've been so spoiled by Moore's law, this idea that every 18 months our computing power will double. We've been so spoiled by that we're not quite ready for the emergence of Amdahl's law, that no matter how many processors we add, that eventually our computing power will actually decline. And because of this need for more power, more processing speed, we're going to have to be looking for new solutions, new architectures, and that's why we are going to have to look at quantum computing no matter what else happens. Also, not to mention the fact that a quantum computer is really properly capable of finding those needle in the haystack problems. We can use it for amazing things, like figuring out new medicine, figuring out new energy technologies. We can do so much cool scientific problem solving with it that promise itself holds something that's incredibly attractive. But beyond that, when you talk to a computer scientist or an information security specialist, they find it terrifying because there are other things we can do with a quantum computer that pose a threat to the way that we currently secure ourselves across the scale of the internet. What we use to secure ourselves is cryptography. We encrypt data in order to protect that data from people who are not authorized to see it. However, all of that problem, the cryptographic problem that's created so that attackers cannot decrypt that data, it's based on fundamental math problems. The two basic math problems that are involved are called integer factorization and discrete log. This is high school mathematics. And the high school mathematics that's there is saying if we take two very large prime numbers and we multiply them together, we do something called a one-way function, which means it's easy to do in one direction and difficult to do in the other. So the strength of the one-way function, it's dependent upon how long do you need to solve it. So if I would ask anyone here now, what's 9 times 8? 72. Yay! What are all the numbers you can multiply together to get 72? I don't know. Well, you do know, but it'll take you a while, right? So it takes you some time to figure out how you get to all those numbers. And our current computers, they work the same way. If you ask them to multiply two large prime numbers together, they can tell you the answer right away. But if you ask them to reverse that and say, wait a minute, I have this very large number now, how do I get to those smaller numbers? They have a hard time. Our brains work the same way that our current computers do. A quantum computer, on the other hand, doesn't have this issue. Because of an algorithm from Peter Shor, and no, not this Grover, a different Grover, Love Grover, because of these two gentlemen, we have algorithms that'll actually help reverse these one-way functions and give us those raw, original starting points. Is this idea clear? I hear a all right. Well, so look, you can't just put crypto on everything and think we're secure against the Chinese and the Russians and the Iranians and all those other foreigners. I'm just kidding, that's a joke. What you really need is you need a very solid understanding of what it is you're trying to protect and from whom. From whom? What are their resources? What are their capacities? What kind of solutions do they already have? Maybe they don't need a quantum computer. Maybe they have someone really smart in the mathematics department in a basement that they've chained to the thing and found a mathematical weakness to some of these algorithms. So in order to get really good security, you need to have secure hardware, which we don't, secure operating systems. Does anybody know how to say Windows? Secure protocols, a lot of them are broken, secure applications. Then, if you have all of that, you can apply good cryptography and still have that fundamental understanding of your attacker. Most people, most companies, and most countries have no clue how to do this. That's why every day you hear about another attack. The question about the quantum computer is a fundamental question of when will we get it? Well, your guess is as good as mine. There will be people today that you'll hear from that will probably be able to tell you that better than I. But even if you listen to a quantum skeptic, who might say never, we're still looking at like between 5, 10, 15 years, but it will be there at some point in time, and we need to get ready. The, thing that I want you to remember when it can break stuff is the bigger the quantum computer, the less time it takes us to break some of these algorithms. So if we have a really big quantum computer, it can take a problem that would have taken the lifetime of the universe to solve. It can take it back to a couple of seconds. Lifetime of the universe, hard problem, to a couple of seconds, hard problem. So you can also figure out what the 72 is from that type of scale. Yeah, a lot quicker than you could before. There's another issue of capture now, decrypt later. This is a photo of the Utah data center facility, which collects copies of internet traffic. This is a real facility by the NSA. It exists in Utah. You can look it up on Google Maps. The idea is that they're capturing all of this traffic, including the encrypted traffic. They hold on to it, waiting for either a mathematical attack or a quantum computing attack, because old secrets are just as good as new secrets, because they can tell you something about what you're going to get. Yeah? So when we try to figure out, what do we do now? It looks like we're screwed. Well, first let's answer these 3 questions. First and foremost, how long do you need to keep your encryption secure? It depends on what data you're trying to protect. Are you trying to protect your banking data? Are you trying to protect your healthcare data? Are you trying to protect some other data about what you ordered at bol.com? Whatever the data is that you're trying to protect, it has a certain lifetime that you want to protect it for. You might want to protect it for a few weeks, a few months, maybe your lifetime. If it's the latter, we don't know how to do that. We do not know how to keep data secure for that long. So the second question is, how long before we have a viable quantum computer? Now, I just told you, between 5 to 10 to 15 years, but it'll come, somewhere in that range. So if we say we want to protect something for the lifetime of a person, like DNA data, and we know that there's going to be a quantum computer in this time, then the last question you want to know is, how long before I get to something that's really safe? Well, I can tell you that that'll take between 10 years as well. So we're nowhere near there. That means we should start preparing now. So I think there's a phased plan of defense that we can actually instill. We need to first and foremost, on all of our algorithms, make sure they're hard as possible to crack. That means the key length, the big number, needs to be really big. So we need the maximum key length of all of the current algorithms that we currently have. The second thing is we need to look for opportunities for quantum key distribution, using the properties of quantum mechanics that we actually build secure networks at the transmission layer. And finally, we can use something called post-quantum algorithms. So instead of the old hard problems we had, we come up with new hard problems that even with a quantum computer, it cannot be cracked. Yeah, new math. And I really think that we should be thinking about that quantum key distribution quantum network issue, because when you take a look at our other countries, like China, they've been busy with it for a rather long time, and they're only getting better. So the same type of investment and opportunity should be existing in other countries in order for us to also secure our defenses before we think of an offensive strategy. And that means building things like a quantum internet, which is inherent for strong security for the future. Building algorithms, we're going to have post-quantum algorithms in 2024. The idea for all of you is to go out there, figure out what they are, not only use them yourself if you're building things, but also see what your suppliers use in order to make sure that the whole ecosystem that you have across the internet is equally secure. So it's about supply chain and risk management. And you need to be able to be in a position to evaluate threats, because some of those initial algorithms were already broken, and not even with a quantum computer, but with a regular computer. So you need to be able to understand which algorithms are good, and the name of the game is crypto agility. So if there's something that's broken, you can replace it with something that works. And you should know there are already secure post-quantum applications out there today. You can use it for online applications like Secure Shell, you can use it for chats, you can use it for VPNs. They're already there. But the coolest thing, you might have seen this, Apple. It's not the introduction of an iPhone, but Apple added a post-quantum algorithm to iMessage. So you all can do this if you're using iMessage. But you should remember that iMessage, if you're in lockdown mode, will be turned off because of the vulnerabilities that were there. So you still need to secure the ecosystem before you can use a post-quantum algorithm. And I want to remind you in closing, security is a journey, not a destination. You need to keep trying to get yourself continuously secure. So you iterate and you improve. You need to make sure you have the support, not only of each other and your community, but also of your leadership. And we need to have a national call to action here. You can all start playing with Quantum, get your hands dirty, and talk about it to each other. That's the only way we will be secure for the future. So, thank you.